Greetings, my name is Chastity Selma Jhingree, and today's topic is Cartesian coordinate plane. The Cartesian coordinate plane looks like this. That has x-axis and y-axis. The x-axis is horizontal, left to right, and the y-axis is vertical, up and down. Coordinates are points that are written of the form x, y. The Cartesian coordinate plane is divided into 4 quadrants. In the upper right-hand corner is quadrant 1, x, y. In the upper left-hand corner is quadrant 2, negative x, y. In the lower left-hand corner is quadrant 3, negative x, negative y. In the lower right-hand corner is quadrant 4, x, negative y. When plotting points, x, y, x before the comma is the x-coordinate, and y after the comma is the y-coordinate. We begin with the x-coordinate that is read from the x-axis, and then from the x-axis we go up or down based on the value of the y-coordinate. For example, 2, 1. We begin at 2 and go up 1, which is this point. Negative 2, 1. We begin at negative 2 and go up 1, which is this point. Negative 2, negative 1. We begin at negative 2 and go down 1, which is this point. 2, negative 1. We begin at 2 and go down 1, which is this point. We have a well-defined collection of points, which is known as a set of points. A set of points in a plane is known to be a relation, which we have a set of points in a Cartesian coordinate plane. These set of points can be written in roster notation. Roster notation, we begin with braces and in braces and separate each point that are written as coordinates with a comma. So in our case, it will look like this. Another way to write a set of points would be set-bearer notation. Set-bearer notation, we begin with braces and in braces, an element in a set, colon represents such that so an element in a set such that properties of the element is in a set. For example, x, 1 such that negative 2 less than or equal to x less than 3. An element in a set of points is x, 1, such that properties of the element in a set of points is negative 2 less than or equal to x less than 3. We have less than or equal to and less than. Less than or equal to means a number is included and just less than means a number is not included. Similarly, if we had greater than or equal to means a number is included and just greater than means a number is not included. So in our case, we have negative 2 less than or equal to x less than 3, which means that negative 2 is included but 3 is not. So our set of points would be negative 2, 1, negative 1, 1, 0, 1, 1, 1, and 2, 1, which will plot them on a Cartesian coordinate plane that looks like this. As you noted, we do not have 3, 1, because 3 is not included. We will now observe points that are being reflected in respect to the x-axis. Reflection in respect to the x-axis is considered to be symmetric about the x-axis. Symmetric about the x-axis. Given 2 points, x1, y1, and x2, y2. If x1 equals x2 and y1 equals negative y2, where the x-coordinates are the same and the y-coordinates are a negative of the other, then the 2 points are symmetric with respect to the x-axis. For example, points A and D. A is 2, 1 and D is 2, negative 1. The x-coordinates are the same and the y-coordinates are a negative of the other. Similarly for points B and C. B is negative 2, 1 and C is negative 2, negative 1. The x-coordinates are the same and the y-coordinates are a negative of the other. Also, we'll observe points that are being reflected in respect to the y-axis. Reflection in respect to the y-axis is considered to be symmetric about the y-axis. Symmetric about the y-axis. Given 2 points, x1, y1 and x2, y2. If x1 equals negative x2 and y1 equals y2, where the x-coordinates are a negative of the other and the y-coordinates are the same, then the 2 points are symmetric with respect to the y-axis. For example, points A and B. A is 2, 1 and B is negative 2, 1. The x-coordinates are a negative of the other and the y-coordinates are the same. Similarly for points C and D. C is negative 2, negative 1 and D is 2, negative 1. The x-coordinates are a negative of the other and the y-coordinates are the same. For symmetric about the origin, given 2 points x1, y1 and x2, y2. If x1 equals negative x2 and y1 equals negative y2, where the x-coordinates and the y-coordinates are a negative of the other, then the 2 points are symmetric with respect to the origin. For example, points A and C. A is 2, 1 and C is negative 2, negative 1. The x-coordinates and the y-coordinates are a negative of the other. Similarly for points B and D. B is negative 2, 1 and D is 2, negative 1. The x-coordinates and the y-coordinates are a negative of the other. We will now observe points that are on the x-axis. For points to be on the x-axis is considered to be the x-intercept. X-intercept. Given a point x, y and an integer a, if a point is on the x-axis, then we have an x-intercept of a, 0. For example, points A and C. A is negative 2, 0 and C is 2, 0, which are on the x-axis. Also, we'll observe points that are on the y-axis. For points to be on the y-axis is considered to be the y-intercept. Y-intercept. Given a point x, y and an integer b, if a point is on the y-axis, then we have a y-intercept of 0, b. For example, points B and D. B is 0, negative 2 and D is 0, 2, which are on the y-axis. Thank you for listening.